Welcome to aminacademy.com. In chemistry, let us discuss about Lewi's electron dot structure. Lewi's electron dot structure is also known as a Lewi's dot formula, Lewi's dot structure, electron dot structure, or Lewi's electron dot structure, LEDS, are diagrams that show the bonding between atoms of a molecule as well as the lone pairs of electrons that may exist in the molecules. Here, Lewis, an American chemist, came up with important theories of bonding, but also gave a new definition to acids and bases also. Further explanation: both ionic and covalent bonds involves valence electrons. The electrons in the outermost energy level of an atom is a valence electron. Lewis, the American chemist, shows that with a system to represent the valence electrons of an atom, this system known as electron dot diagram or Lewis structure. It uses dots to represent valence electrons. Lewis system is a valuable model for covalent bonding. However, these diagrams do not show the actual location of the valence electrons. They are models that help you to keep track of valence electrons. What is a valence electron? An electron that is found in the outermost shell of an atom, and that determines the atom's chemical properties. Here, the Lewis structural formula, in which the electrons are represented by dots, dot pairs, or dashes between two atomic symbols, represent pair in covalent bonds. Lewis structure models covalently bonded molecules. A Lewis structure shows only the valence electron in an atom or molecules. The nuclei and the electron of the inner energy level, if any, of an atom are represented by the symbol of the element. With only one valence electron for that hydrogen atom has the electron configuration as 1s1. We know that. When drawing hydrogen's Lewis structure, you may represent the nucleus by the element's symbol H. The lone valence electron is represented by the dots. For example, we know that hydrogen symbol hydrogen, we know that the symbol is H. Here, hydrogen have one valence electron, therefore, Lewis structure is, you have to put H and put one dots. When two hydrogen atoms form a nonpolar covalent bond, they share two electrons. These two electrons are represented by a pair of dots between the symbols. For example, two hydrogen atom at right, put two dots. Two valence electrons shares each other. Here, already we discussed about valence electron. One more time we'll do. Any of the fundamental negatively charged particles in the outermost region of atoms that enters into the formation of chemical bonds. Whatever the type of chemical bond, ionic, covalent, or metallic, between atoms, changes in the atomic structure are restricted to the outermost or valence electron. The Lewis structural formula, in which the electrons are represented by dots, dot pairs, or dashes between two atomic symbols, represent pairs in covalent bond. Now we'll do some example problem. Here, lithium, the symbol is Li. here that electron configuration is, you know, that 1s2, 2s2. Here the valence electron is 1. Therefore, the dot structure is, we have to write Li, put 1 dot. This is a Lewi's dot structure for the lithium. We have, suppose boron. Boron is, the symbol is B. That electronic structure is 1s1, 1s2, 2s2, 2p6. 2p6, no, 2p1. Yeah. Here, 2p1. Then here atomic number is 2 plus 2, 4, 4 plus 1 is 5. Then here the valence is, number of valence electron is 3. So we have to write boron, the symbol B, and 3 dots. This is a Lewi's structure for boron. Now, for suppose neon, Ne, the structure electron configuration is 1, 1s2, 2s2, 2p6. Here number of valence electron is 8. That means outermost orbit is filled. So you have to write Lewi's structure, neon. Here 2 dots here, 2 dots here, 2 dots here. Suppose the chlorine, 2 chlorine atoms come together, that is chlorine plus chlorine gives, the structure is chlorine. You have to write chlorine together, and like that you have to write. That means each chlorine atom in Cl2 has 3 pairs of electrons that are not part of the bond. Here, these 3 pairs of electrons, this one, this, and this one, like this. The pairs are called unshared pairs. These are unshared pairs or lone pairs. The pair of dots that represent the shared pair of electron can also be shown in by a long dash also. That is here, this is a single bonded here. These 2 shared electrons here. Now we can write with, for the single bonded same way, we can write this way also. Like here, put Cl. Instead of 2, we have to write a bond, single bond, then dot structure is here. We can represent like also. That means this single bond represents these 2 dots. We have done. Please subscribe our YouTube channel.